Hey there, this is Math 6, Unit 6, Lesson 5, a new way to interpret A over B, or in other words, A over B, which is what we're talking about today. Alright, so it says, let's investigate what a fraction means when the numerator and denominator are not whole numbers. Okay, so first we're going to recall some ways of solving from things we've done just a few lessons before. And we have, says, solve each equation, be prepared to explain your reasoning. So we have 0.07 equals 10m. Okay, so to solve this, there are a couple ways I could go about doing this here, right? Now in this case here, I have a decimal. Now this decimal number is 7, and we look at the place, this is tens, hundredths. This really is 7 100ths is what that actually is. So 7 100ths is equal to 10m. Okay, so one thing I can think about is I can think about this being 7 hundredths, and to then get the 10 to move to this side and the m to be by itself, instead of doing times 10, I would multiply by 1/10, right? Because 10 times 1/10 becomes 1. So if I multiply this side by 1/10, then what I actually have, this cancels out, is I have 7 on the top there over 10 times 100, which is 1,000, equals m. And that, of course, can be written as, this is 7 thousandths, that's 0.10, 100, 7 thousandths, like so. I could also look at it as 0.07 equals 10m, and I just divide by 10 on both sides, so that goes away. So I have 0.07 divided by 10. And to solve this out here, we can say 10 goes into 0, here's a decimal point still, 0 times, 10 goes into 7, 0 times, so let's put a 0 here, 10 goes into 70, 7 times. And so that's how you end up with 0.007 there as well. So both methods will get you to 7 thousandths as a solution, and it's just kind of a way of looking at that one there. Alright, so on this side, we look at number 2. What we're talking about is we have two things joined together by addition. So in order to get the t variable by itself, I want to subtract 7.2 from both sides. And in doing so, this becomes 0, leaving me with just the t on this side. And then over here, this becomes a 9, that becomes 11 minus 2 is 9, keep our decimal point, and 9 minus 7 is 2. So we're just showing how we can reason this through to find the solution for the variable and get the variable on one side. Okay, so we take that then and we move into today's activity, which is interpreting A over B. Alright, and we have a series of 5 equations. They just say solve. So when we look at A over B, another way of thinking about A over B is this is also A divided by B. That's another way of interpreting what a fraction is. So when I have 35 equals 7x, and I want to then get the x by itself, then I'm dividing this side by 7, and I'm dividing this side by 7, which makes a lot of sense. This is basically 35 divided by 7 equals x. So yes, you could view it as a fraction, 35 sevenths, right? But it's also 35 divided by 7, and 35 divided by 7 is simply 5, and so 5 equals x. So these two representations, these two things, actually are the same thing. 35 over 7 is the same as saying 35 divided by 7. Just like right here, 7 over 7, 7 over 7, is the same as saying 7 divided by 7. Because 7 divided by 7 is 1, and this one is also equal to 1. Let's take a look at what that looks like then for number 2. So for number 2, we have 11x equals 35. So I'm going to divide both sides by 11. And 11 divided by 11 is 1. So this becomes simply 1x over here. And 35 divided by 11, I really can't do much with that. I could leave it just like that. I could then make it as a mixed number if we chose to do that, but for what we're doing here, not that important. So this becomes 35 over 11, or another way of writing it would be 35 divided by 11 equals x. The dilemma with writing it like this is it looks like I need to continue doing some math there, right? It's like another equation. I want to keep going. But if I leave it like this, then I can leave it simply as a fraction and leave it as 35 over 11. Alright, let's look at number 3. So for 3, we have 7x equals 7.7. So to get this one solved, we're going to go ahead and divide by 7 and divide by 7. This becomes 1, so we have x here, and x is then equal to 7.7 divided by 7. And if you were to kind of think that through a little bit, well, what's that look like? Here's 7, and here's 7.7 divided by 7, what looks like as a regular division problem. 7 goes into 7 one time, keep our decimal, 1 times 7 is 7. Get 0 there, bring down this 7. 7 goes into 7 one time, 1 times 7 is 7, and we're at 0. So x in this case equals 1.1. Right? So that's what we're up to there. When we get to this one, we have decimals now, right? A decimal and a decimal. So I'm going to divide both sides by 0.3, divide by 0.3. So x is equal to 2.1 divided by 0.3. So if I write it out like this, 0.3 goes into 2.1, move the decimal 1, move the decimal 1 and put it up top right away. 3 goes into 2 0 times, 3 goes into 21 7 times, 7 times 3 is 21 with nothing left over. So that tells us that x simply equals 7. Alright, so we can divide by a decimal the same way we divided by a whole number. And so you can see we're just progressing whole number, two whole numbers that just stay a big fraction, a decimal divided by a whole number, and now a decimal divided by a decimal. So then we look at one last example and we have a fraction over a fraction. The same thing is going to be true. I'm going to divide both sides basically by 1/2. You might have talked about multiplying by a reciprocal before, but it's the same idea as dividing by a half. That's what I'm doing. Because again, this is a number divided by the same number, which reduces down to 1. So what I'm left with on this side is what? It's 2/5 divided by 1/2 equals x. And the way we usually write that when we divide by a fraction, yes, we change, we flip it, you might say in your classes here and there, but we take this and we multiply by the reciprocal, which is 2 over 1, and we multiply that out. 2 times 2 is 4, 5 times 1 is 5, so 4/5 equals x. But this works like that because it still is 2/5 divided by 1/2, and that's what we have there. Okay, so there's your idea for that one right there. Let's turn to the next idea. We have one more thing. We have telling a story on 5.3. Short lesson today. And what I want you to do is take turns with your partner telling a story that might be represented by each equation. Then, for each equation, choose one story, state what quantity x describes, and solve the equation. If you get stuck, draw a diagram. Okay, so we have two equations here. They want you to make up a story with your partner about what this could represent, and then decide what does x actually stand for in each equation, and then solve it. Okay, you're going to have a very similar question to this on your homework as well. Alright, so keep that in mind. So let's look at this first one. This first one could be a story like something like this. I could say that Sam bought a pack of gum for 70 cents, right? For 70 cents. And some other items, right? And what do the other items stand for? Well, other items are going to be other things. And we could say he paid a total of $12. And we could ask how much were the other items. Okay, and so x is going to be the value of what? In this case here, the other items. If we were to solve that, we would have to do a little bit of work there. We'd have to then subtract. We do 12 minus 0.7. We subtract 7 from both sides, and that becomes 3 there, and we have 11.3 equals x. I ran out of room there writing my story. Okay, so that's the idea for that one. 11.3 equals x. So that's one story there. The next one, number 2, we could write a story something like, we could say 1/4 of a container of rice is three and a half cups. All right, so 1/4 of a container of rice is 3 and a half cups. How many cups of rice are in the whole container? And that could be my question there. Okay, so 1/4 of a container of rice is 3 and a half cups. Okay, what does the X stand for? X in this case here is going to be, in our case here, 3 as a quarter of it's the container of rice. That's the container amount of rice. And to solve that, we would do 1/4 X equals 3/2. We would then multiply by the reciprocal, or divide by 1/4, which means then to change it around. That becomes 12/2, which reduces down to 6. And so X equals 6 in this case here. Alright, so just as we said before, in the past you learned that fractions such as 4/5 can be thought of in a few ways. 4/5 is a number you can locate in a number line by dividing the space between 0 and 1 into 5 equal parts, right? 1, 2, 3, 4, 5. And so 4/5 could be this location right there. It's 1, 2, 3, 4 out of the 5 sections there. That's one way of thinking about 4/5. Another way to think about it is that it's a way we think about sharing things. And so if 4 wholes were shared equally among 5 people, that's 4/5, which is really resulting in dividing 4 by 5. So a couple ways of thinking about how that works there. So we can extend this meaning of fraction as division to fractions whose numerators and denominators are not whole numbers. So if we have 4.5 divided by 1.5, that's the same, or 4.5 over 1.5, that's the same as saying 4.5 divided by 1.5. And it works out to be the same answer, 3. For a fraction that involve non-whole numbers, okay, we can also use those to solve equations. So here's an example of 3/8 x equals 4/3. So that's our starting point there. And we can see if we divide both sides by 3/8, so this is 4/3 divided by 3/8 right there. Then when I divide by 3/8, it actually means to do what? I'm going to multiply by that reciprocal there. All right, so I multiply that reciprocal, and in doing that, I get 32 over 9, which can be changed to a mixed number, 3 and 5/9 there. Alright, so that's just some things we were talking about today. We're going to pause there, give you a chance to work on your homework, and then we'll come back and check it together in a moment. Alright, so here's homework for Math 6, Unit 6, Lesson 5, a new way to interpret A over B. First it says select all the expressions that could equal 3.15 over 0.45. So we really talked today about the different things this could mean, or different ways of writing this. But this number is the same as saying 3.15 divided by 0.45, because this bar means division, which means we could also think of it a different way. This value here, if we separate the two parts together, if we put 3.15 by itself, and then we multiply it by 1 over 0.45, right, that is still the same thing there. So we could separate it out like that, or think of it as just 3.15 times 1 over 0.45. Those things are all okay there, right? Okay. Yep, that gets you the same spot there. So now then, if we think about, let's see what else we have. So that's a couple things. So let's start there. So here we have 3.15 times 4.45, which is not what we need to do. We need to divide by that. So that one's definitely not going to be okay. This one we can see it's the same idea but division, which we have here. So we like this one. That's going to be great. Here we can see 3.15 times 1 over 0.45 like we just talked about. So that looks good there. This one we have 3.15 divided by 45 over 100. Well, what does that mean? Well, let's take a look at this. 3.15, if I divide by 45 over 100, 45 over 100 is 45 hundredths. Okay, what is this one right here? This is 45 hundredths. So if I was to rewrite this real quick, this is 3.15 times times 1 over 45 hundredths. Well, let's not rewrite too much. 1 over 45 100ths. This is going to get too crazy, so don't worry about that one. Ignore that a little bit. So divided by 45 hundredths means actually to multiply by the reciprocal. So we're going to multiply by what? 100 over 45. All right, so that's the same thing. We can see those are the same problems here. So the question is, are these actually going to be what we're doing up here? Okay, well, if we're dividing by 0.45, this is dividing by 45 hundredths. So these actually match, don't they? One's a decimal, one's a fraction. So knowing that these match, that makes this one accurate. And then when I multiply by the reciprocal, I have this there, which is the reciprocal of that, which means this one is also going to be true. This one is just taking the two and flip-flopping like that, which is not something we can do. So we would say B, C, D, and E. Okay? So it sometimes helps to write them out to see how could you get these other ways of showing it. Number 2, which expressions are solutions to the equation 3/4 x equals 15? Select all that apply. Sure. So we're going to look for some solutions here. So if I have 3/4 x equals 15, I could multiply both sides by 4/3 so that x equals 15 times 4/3. Now, do we see that anywhere here? Well, here's 4/3 times 15, and there's one right there. That's going to work okay. So that's all right. This is 15 times 3/4, so we couldn't change that. We only changed the kind of the order of the numerator and denominator if we're dividing. It's not multiplying, so that one's not going to make sense for us. When we look at these ones here, let's take a look. We have 15 divided by 3/4 or 15 divided by 4/3. Well, this is 15 times 4/3, so that's not going to work out okay. So that's not going to be the same as this one. That's not going to be okay. But what if we did if we had 15, let's look at this right here. 15 divided by 4/3, and we rewrote that. If we rewrote that, we would have 15 divided by 4/3. Again, we're trying to get to this spot because we know that's our solution. If I had to solve this, what would I do? I would do 15 times 3 over 4, right? So 15 times 3 over 4 is not the right thing. But what if we did 15 divided by 3/4? Well, that becomes 15 divided by 3/4, which means I multiply by the reciprocal, 15 and 4/3, and look at that. That does match what we're aiming for. So this one, choice A, 15 divided by 3/4, is the right thing. And then notice right here, what do you see? 15 divided by 3/4 is this one right there, so E is also correct. So A, C, and E are the correct solutions there. Number 3, we're going to solve each equation. So this one, we're going to divide both sides by 4. 32 divided by 4 is 8, so x equals 8. On this one, we're going to divide both sides by 32. And 4 divided by 32, can't do much with that. That is a fraction. 1/8 equals x. Over here, we're going to divide both sides by 10. So x equals 26 divided by 10. When you divide by 10, we just move the decimal one spot, so we get 2.6. And over here, we divide both sides by 100. So x is going to equal 26 hundredths. Well, here is 26, and we're in the hundredth spot. So that's all there is to it right there. All right, on the next side, it says, or the next question, it says, for each equation, write a story problem represented by the equation. For each equation, state what quantity x represents. If you get stuck, draw a diagram. And like we said in the lesson, this is the same thing we did in the lesson. So let me show you the picture here of the equations. And it says 3/4 plus x equals 2, and 1.5x equals 6. So I'm not going to actually give you a story here. And the reason I'm not going to give you a story is I gave you a story in the lesson, so you can go back and look at that if you like. In terms of the solution, we would subtract 3/4, subtract 3/4, and x would equal 2 minus 3/4. Well, 2 minus 3/4 is going to be 1 and 1/4. Okay, and the reason that's the case is this is 2 is the same as 1 and 4/4. minus 3/4 because 1 and 1 is 2. 4 minus 3 is 1, so we end up there. And over here, if we want to solve this one out there, what's going to happen is we're going to have to divide both sides by 1.5. And so we divide by 1.5, divide by 1.5. So 6 divided by 1.5 is going to mean x equals 4. Now we can do that like this, 1.5 and 6, move it over one space, which means I got to move this decimal over one space there and put it up right away. 15 goes into 60 4 times, with none left over, so x equals 4. Alright, and finally, or not finally, quite yet, number 5. It says write as many mathematical expressions or equations as you can about the image. Include a fraction, a decimal, or a percentage in each. So, think of some different things you can make with all this. We have a fundraiser goal of $250,000. We can see that they've already reached $110,000 of their goal so far. We can see a nice number there, 50,000 out of 250,000. The one I made up real quick is I thought about a question that might say, what percent of their goal have they reached? And to answer a question like that, I would say they have 110,000 out of their goal of 250,000, which equals 0.44, which at the percentage becomes 44%. Now that's just something I see there. Again, you need to come up with some other expressions. You can use any number you want, really. You could do what is 50% of 250. You could do what is 100% of 250. So you make up some stuff there, what's going to work for you. I'm just giving you one example there. And number 6, it says, in a lilac paint mixture, 40% of the mixture is white paint, 20% is blue paint, and the rest is red. Alright, so what do we have? We have white, we have blue, and we have red. And we know we have 40%, 20%, and whatever's left is going to total up to 100%. Do we know what the red percent's going to be? Can we figure that out? If this is 40 and 20, that's a total of 60 right there, which means what's left? 100 minus 60 is 40%. So the red's going to be the same as the white. Now let's keep looking at what it says. There are 4 cups of blue paint in the batch of lilac. So there's 4 cups here. The questions are, how many cups of white, how many cups of red, and how many cups of the whole paint would you end up at the end with? Alright, if we know that blue is 4 cups, what is the relationship between 20% and 40%? Well, 20 times 2 gets you to 40, right? So what is 4 times 2? 4 times 2 is 8. So basically the white amount is double the blue amount, but so is the red. So 4 times 2 this way is also 8. So you use 4 cups of blue, 8 white, and 8 red for a total of how many cups? We have 16 plus 4 is 20 cups altogether. So we have 8 white, 8 blue, and 20 altogether. Okay, and our last one here, it says triangle P has a base of 12 and a height of 8. Triangle Q has a base of 15 and a height of 6.5. Which triangle has the greater area? Okay, so for the triangles, we're going to multiply 1/2 times base times the height. That's what we're going to be doing. So let's look at our choices here. For P, we have 1/2 of 12 times 8. For Q, we have 1/2 of 15 times 6.5. I'm putting times there like that, just so we don't get confused with that decimal. Okay, so without worrying about the halves for a second, because we know they both have a half, we can look at these numbers here. Well, 12 times 8 is 48, and 15 times 6.5 is 48.75. So when I divide both of these numbers in half, this one is still going to be greater because I'm starting with a larger number. Not by much, but Q is definitely going to be greater than the other one there. Okay? Actually, I divided it in half. Sorry, I skipped my notes there. This should say 96, and this should say, apologize, 97 point, for my notes, can't read them very well, 97.5. Okay? 97.5. So So then we divide it in half, you end up with 48.75, and this becomes 48. So just to prove that that one actually is there. Sorry, I skipped that in my notes. That's it for today. Have a great day. We'll see you next time.